Greetings everybody and welcome to episode 3 of my video blog. This vlog is a proper word. I am Harold C. Connolly Jr., Professor of Earth and Planetary Sciences at the City University of New York and Mission Sample Scientist of OSIRIS-REx, NASA's New Frontiers 3 mission to asteroid Bennu, where we will study it for a year and bring back up to 2 kilograms of sample. I am coming to you from the University of Hawaii at Manoa. I am actually in the sub-basement in the IM Microprobe lab. I'm going to show you this instrument right now, which is state-of-the-art IM Microprobe. And basically what happens with this instrument is the samples are placed into this area here, and then you have a plasma beam that hits the sample, either positive or charged plasma that hits the sample is sputtered off. You get molecules and atoms that shoot down into this mass spectrometer that gets separated out, and it's used to measure either stable isotopes such as oxygen, of which there are 3 isotopes, 16, 17, 18, or radiogenic isotopes such as short-lived radionuclide aluminum-26, which is a major relative chronometer for primitive planetary materials, or the first materials are formed in the solar system, when the solar system was nothing more than a protoplanetary disk that surrounded the sun. And part of what OSIRIS-REx is going to be doing is when those samples come home, labs like here at the University of Hawaii at Manoa, the Keck Laboratory of Cosmic Chemistry, will be helping to analyze the samples that we return so that we can better understand the origin and evolution of primitive planetary materials, which are the materials from which the Earth is made from. The surface of the Earth is not very old for the most part. It is recycled due to plate tectonics, also impacts, and of course erosional weathering processes, wind, rain, etc., that constantly change the surface of the planet. If you want to understand what material the Earth was made from, the only source we have for that are meteorites. In particular, chondritic meteorites, which are known as primitive meteorites or primitive planetary materials, because both long-lived radionuclides have shown, as well as short-lived radionuclides in the relative chronometer sense, have shown that these are the oldest rocks in our collection. They are 4.567 billion years old, the oldest materials we have, and the Earth was made from these rocks. They're called primitive, in fact, because, and I'll show some of these to you in the near future, their composition, the bulk composition of these chondritic meteorites, with the exception of volatiles like hydrogen and helium, most closely match the composition of the photosphere of the sun. So you're holding a rock in your hand that actually has a composition of the sun, which is incredible. So Bennu, asteroid Bennu, is by remote sensing techniques compared to these primitive planetary materials as being the best analog materials that we have for understanding what this asteroid is. However, we don't know for a fact. So you're collecting a sample. Amongst the many reasons to collect a sample is to better understand the origin and evolution of Earth-like planets, as well as prebiotic compounds, which chondritic meteorites are rich in. This is actually an SEM, a scanning electron microscope, which is used to magnify to very high magnification the surface of rocks. So basically, this is a laboratory whose function is analyzing rocks here at the University of Arizona. It's a quick tutorial on meteorites, chondritic meteorites in particular, C-H-O-N-D-R-I, chondrites, C-H-O-N-D-R-I-T-E-S, chondrites. I'm talking too fast. I'm trying to get this video done before anybody else comes back in the lab. It's rare that it's empty. So enjoy, aloha from Hawaii, and stay tuned for my next video blog. Bye.